Hello, everyone. Let's wait for a couple of more people to join.
Hello, everyone. Let's wait for a couple of more.
Okay. Right, that was interesting. Yep, I think the echo is gone now. And alrighty, how are we doing today? Well, this is a smoother start than last session. In case you guys joined the last session, this is so much smoother. I'm so much happy. All right, let's just wait for another couple of minutes while people join in. Until then, do hop on to the schedule to check out what's happening today, and do check in for this event. Since you've turned up, you might as well get some swag for it. Let me see if I can display the link for you. Right there, you go. That's where you can register and check in, and it will be counted as one of your 3 live sessions that you're supposed to attend. Thank you. Someone called me an artist. I know it was a weird session last night, but I'm so glad most of you joined in, and it was really encouraging. Some of you even messaged me afterwards saying that you enjoyed the session, which is something I was aiming for. So great. You want the link in the chat? Sure. Let me post the link in the chat. Alrighty. There you go. All right. So a quick check-in. Do you guys need me to walk you through the check-in process, the registration process for today's session, or should we dive right in? No, I'm not going to teach you what I build. We're going to sit and design a project all from scratch. So I'll be taking ideas for what you want to build. So you might want to stick around to maybe suggest a good idea. Yes, I'll be taking all sorts of suggestions of sensors as well when we sit down and brainstorm the idea. So stick around. All right, let's get started. So, before we continue into today's session, I think we had a rather abrupt end. So, let me start right here. So, we will just go over this concept once. In case you missed out on the last session, that's all right. I'm going to do a quick recap in just 5 minutes. All right. So, we were discussing Rtos versus Gpos, and I think I made the point pretty clear. But just so we're clear, did we have any questions regarding Rtos? And would you want me to explain it just again once? Just gonna go. Okay. So no questions for Rtos versus Gpos. That's great. So this is basically a chart I wanted you guys to have a look at. It's basically a priority chart. So, this doesn't happen in a GPOS per se. This is very, very an RTOS feature. And these are some of the points about how you choose an RTOS. All right. So, you don't need to know the terms, you just need to get acquainted with the terms. We'll be using the terms eventually. So schedulers, software timers, queuing mechanism, execution trace tools, low memory footprints, these are just some terms that I want you to get acquainted with. They're basic, they're as intuitive as it gets, right? A scheduler is basically how you schedule your tasks, because an RTOS is a real-time operating system and you want tasks to happen as per the schedule, unlike your GPOS, which just reacts to the event that's happening. Software timers are basically, so real-time timers are timers that keep a track of the time that's happening. You must have heard RTC a lot, real-time clock. So that's used a lot in your devices. Your anything that displays time, it uses an RTC. Software timers are timers that are so you use a software to kind of count the seconds and time every task that has to be done. All right. Okay, thank you, Shrikaran. I will hit this. Might as well. Okay, I think this should be better. Okay. Okay, so queuing mechanism is, let's say you have multiple tasks. How does your software or your RTOS handle the queuing? How does it handle the blocking of different tasks? That is something that you should look into when you're choosing an RTOS. Again, don't bother with the details. I just want you to be acquainted with the terms. All right. Then there is execution trace tools, as to when you've done a task and if you see that it's not the way it's supposed to be, how do you trace back and see what's going wrong? Those are execution trace tools. So in the real time, being able to trace what's really happening. And then there's low memory footprint. I apologize for the misalignment. I uploaded the slides to StreamYard and it's kind of gone wrong there, but it's okay. uh, Low memory footprint, so you do not want the RTOS to take up a lot of memory when it's doing the tasks. You want maximum memory for the task itself. So having a low memory footprint for different tasks is also important. So again, just get acquainted with the term and great. So again, I'm going to ask, are there any questions regarding RTOS? All right. That is not a great impression, but all right. So any questions regarding RTOS? Great. I am going to assume all of you are understanding perfectly well. So, what are we going to do today? We're going to get acquainted with the term protocols. We're going to look at so many different protocols that exist. And then we're going to sit down and we're going to take problems and we're going to actually design the entire solution for an IoT based system. So I'll take problems from you, I'll take feature priorities from you, and we'll discuss and create an entire system. Once we're done creating the system, we will learn how to set up your environment to be able to simulate it. So I'll be walking you through how to sign into Azure, how to use the Azure IoT Hub, what repository you need to download, how to set it up. It's a very simple process. You guys are going to follow along without any trouble, and I'm here anyway if you have any questions. Let's first go over all the networks and protocols, and then we'll decide which one's better. I'm not sure you can compare the two that you're asking though, but we'll see. Alrighty. Okay, so let's start with session 2. Okay, so before we get started, I'm gonna poll for ideas. What problem do you want to solve today? So it can be a simple problem from turning on to light. That's one of my favorite examples when it comes to IoT. Or do you want to solve a slightly complicated problem when it comes to health or a wearable? So I'm looking at the chat. Do you guys have any ideas that you want to give regarding what project you want to build? Okay, so there's someone who has ideas. A very quick example of an IoT system. Okay, awesome. Smart home automation. Great. We'll keep that in mind. Sure, you can. You basically need to think of a problem. I'm not asking you to think of an IoT system. Asking you to think of a problem. Nurses not being able to communicate in a hospital, or street lights. Anything that comes to your mind. A problem that we'll see whether or not IoT can solve later. But let's figure out the problems. Zaid, I'm not sure. You want the check-in link? Or I just shared it, but I can share it again. I've shared it in the chat. Okay, there's another idea. So, okay, that's a cool thing, being able to communicate from second floor to first floor. All right. Awesome. See, this is what I'm talking about. Let's focus on the problems first. We'll figure out how IoT fits into the solution later, or even the solution later. Great. Great problem detected. Uh, That's a great problem too. Let's see if we'll figure out if IoT can solve it later. All right, fire detecting solution. Great idea. I think that's one of, I think in a lot of in-person hackathons, that's one of it's been one of the most famous problems that people solve. So great idea. Do you want the registration link to LHD or just this event? I'll put a link that should help you get to the LHD page. So there you go. Uh, awesome. See, this is what I'm talking about. Water wastage. That's how that's a great problem. Something that needs to solve. Okay, for this event, here you go. So, what do you mean by fuel efficiency across different environments? As in a car running in a desert and a city, or fuel efficiency? How? But great environment. Awesome, awesome. Okay, so I think we've got some great suggestions for problems. So keep these things that you thought in mind. Okay, I'm still getting some really amazing suggestions. This is actually a really good idea. So keep what you're suggesting in mind, and when I walk you through the different parameters and the different protocols, think about the problem and see if your problem, kind of, if the protocol somehow fits your problem. All right. I think IoT has some of the most amazing and creative uses in marketing, and I mean, I have such great examples. One of my favorite ones is I don't know if you know, Nescafe had this bench that if two people sat down, it kind of closed in together, and they were kind of forced to talk, which really made it a good community to kind of hang out in. Great suggestions. All right, so let's move on. Okay, so we can now get into the session. All right, so in case you guys didn't join us yesterday, I'm Ritvi. I'm a new coach. This is my third session live streaming. You guys have been real sweethearts in the first two sessions supporting me while I had a rough time getting along. So I'm a maker. I do lots of crafty things. I have an extensive background in IoT and embedded systems, and I like to hack. And that's how I ended up in hackathons and then in MLH. I love interacting with my community members, so feel free to reach out to me on any of the links. All right, great. Let's move on. Today's agenda. Okay, so we've done intros and icebreakers, so we have something in our mind. You kind of know what's coming up in the session. I'm going to do a quick recap. We're going to cover, we're just going to, remind you a couple of terms that we went over yesterday so that when I use them today, you aren't lost. And then we're going to focus on protocols. It's not even going to take that long. I'm just going to go over them. I'm going to make you realize why so many protocols exist, right? I mean, if you're just connecting the devices and if you can use IFTTT everywhere, why not, right? It's a simple solution. So why do these protocols exist? So we're going to first look at what is a protocol, then some popular protocols that really used, and I'll show you a really beautiful chart about protocols in health and how different protocols come in as per the different parameters. Then we'll do finally the hands-on session where I'll actually walk you through how to set up Azure. You should be able to find yesterday's IoT video in both the Twitch channel and the YouTube channel. It's been uploaded there. Yeah, I kind of did start at session 0 because I want to make sure everyone's on the same page. Okay, let's go. What's a protocol? Thoughts, anyone? What do you think is a protocol? First thing that comes to your mind. Hit the chat. Okay, no suggestions. What's a protocol? Does my internet lag? Great job. That's a great answer. Protocol is not really a system, but I think you're getting the idea. It kind of helps a system come together. You're close, very close. I'm not sure if this is a question or the answer to what I asked you to answer, so I'm just gonna give you the benefit of doubt and tell you that yes, we're gonna be doing a demo later on. Great, great. This is you guys are getting close. You guys have a good idea. I really like this answer. This is as close as it gets. Great. So again, not exactly a system, but rules creating a system is something more close to what we're really aiming for. All right. This is the first usage of protocol that happened, which is basically it was data. It was in context of NLP data, NPL data communication network, and it was first used in 1967. And when we go ahead in the slides, you'll realize the first protocol, like how we use it in IoT today, wasn't even discovered until very much later. But the word protocol is used very commonly, right? It's protocol. A lot of you said is a set of rules, is a set of commands, which is true because you have a protocol to do things in an organization. There is a protocol to follow when there is specific situations, right? That are listed in an organization. So yes, it's a set of rules, conditional rules, right? That happen. That's the general definition. In IoT, though, a protocol is basically optimizing the usage of the network such that both the devices are conditioned to read a certain data in a certain way. Does that make sense? So let's say I'm using Wi-Fi. Almost three different protocols use the Wi-Fi connection. Okay, but the way that the data is sent and the way that it's read by the device is what makes it different. So the protocol is basically a set format that both the devices are supposed to understand. So all of you were very correct when you said it's rules to talk or it's a rule-based system. So great job. You guys are already pretty great at this. So these are the protocols that are very commonly used. So MQTT, Zigbee, CoAP, BLE, and today one of you asked about the ad hoc network, Manit. So I'm going to take suggestions from you about what do you think Manit is, because I found that entire concept pretty interesting. All right, so let's start with MQTT. All right, MQTT is one of the most widely used protocols that I've come across. And I cannot, I mean, you take any device, right, from your smart light bulb to a lot of your health devices. They are almost always using MQTT. EV, one of you mentioned EV marketing. EV swap stations heavily rely on constraint based network protocols, and MQTT and CoAP are really, really, like top used protocols when it comes to EV swap stations. Great question. Great questions. When we're going over the different protocols, I think you should try and select one yourselves, and then we'll look up what a washing machine really uses. Yep, yep. They're all protocols too. But I'll debate that maybe later. Okay, moving on. So, like I said, there are so many types of protocols, right? So, from every layer has a different kind of protocol, and basically, what it is, if you're using that layer to communicate, you have defined a set format that both the ends understand. So, the one device will send that format to the other end of the device, right? And they both understand that. It is also easier to encrypt the data when you do it in a certain way, right? So this is just to give you an idea of how wide this entire world of protocols is, right? So from every layer having its set rules already. There is more rules made to simplify and optimize the layer usage. All right. Again, this is just to give you an idea. I'm not going to focus too much on it, but if you have any questions. Yep, that's correct. That is a good observation. Well, yes, IoT networking. When you talk about IoT networking, the first thing that you talk about is protocols, right? Apart from selecting the layer that you want to communicate, the first thing you talk about is protocols. All right, moving on. So this image is supposed to give you an idea about why there are so many different protocols. Like you saw that there were so many protocols here on a single layer. Why optimize it so much? Because every problem that you want to solve has different constraints. It's a problem for multiple reasons, and you want to make sure that you respect all those reasons. Because if some place there is power, if you want to save the environment and you want to keep a tab of your electricity meter, and you spend as much electricity to just send the you know energy usage, it's kind of useless, right? So you want to respect the fact that you want it to be low powered. You want to respect the fact that it should be able to sleep in and out, it should be able to wake up, and it should not lose data. How much data is it sending? How much data do you want it to be able to send? So these things are very important when you're considering the design of the IoT network. All right. So again, this is a great example of why you would choose one protocol over the other, right? So from these are your first tier internet protocols, right? HTTP, TLS, TCP, IPv6. They send thousands of bytes together at once, but they're also pretty high powered, right? You don't exactly put a power optimization on them. Then comes MQTT, TLS, then there's LoRaWAN, that's one of the really upcoming protocols, right? So they have the fused bytes. They have super optimized information. So in this case, you're sending just the necessary information. And then there is the middle layer, which sends tens of bytes. And of course, this is not like by the book. These things have tons of variations. MQTT itself has multiple variations based on security, based on the number of bytes, based on the type of device that you're using. All right. So MQTT, we've used it so much. This was designed specifically for one problem, right? And it ended up being a standard which solved tons of other problems. But I think Alright, so I think this is I like stories when it comes to protocol science and scientists. So this is one of my favorite stories. Right, they wanted to uh, monitor a oil pipeline in a desert. They had to be careful of the power, they had to be careful of the network availability, they had to be careful about accuracy of the data, because they can't always go and check again and again whether the data is accurate. In that, they came up with a protocol which took into consideration all these things. And this diagram does a great justification of what it's really doing, right? You have a broker, right? You have subscribers, and basically whatever data is sent to the broker gets sent to the subscribers. And you of course have one publisher that's going to be publishing the information. The best part about MQTT is that any of your devices can act as any of your devices. Your broker can publish, your subscriber can publish and be a broker. So if there's why am I saying that? It's because it's to give you an idea of a mesh network. The MQTT works great in a mesh network, right? So this is an MQTT connect message structure. So we spoke about rules, right? How does a protocol have a rule? So this is basically the MQTT rule, right? There is a set um format of the message string being sent, and your device receiving it is going to look for the flags and then reduce the information from it. It's something like passing, right, your information. Correct. Publisher publishes to the broker, and the broker is what the subscribers subscribe to. But again, like I said, the best part about MQTT is your one device does not have to do just one thing. It can do multiple things. So it works really well in a mesh network. So if you want to send information out of seven devices from first device to the seventh device, and you want to make sure that the network and power is optimized, you can do so by kind of making a chain publication, right? So this is just to give you an idea that MQTT is great as a mesh network, right? So a couple of things to note, right? There is first are the flags, right? You have the header, you have the remaining length. These two make sure that the receiving device knows that now what I've received is an MQTT message. Next, how long is the message supposed to be? So if it's not the same length, so let's say your header says 9 and your message length is 7, it will know that there's data missing or there's something wrong with the data, right? Then there is the protocol name and the version, because like I said, it started out as something to solve one problem and it solved multiple, and there are multiple versions of it, right? So that's an important thing. Then there's the connect flag. Basically, like we said, right, there can be a publisher, a subscriber, and how do you define whether the device is publishing, subscribing, connecting? So this is the connect flag. This is telling the other device that this is a connection request, basically. Then there's keep alive, whether you want the connection to be open all the time or do you want it to close after a certain amount of information is passed. Why would you want to do this? Again, power optimization and data accuracy. Also, security of the data. You don't want continuous endpoints open. Then there is the length again, and this is the length of the message. The first one was the remaining length of the entire packet. This one is the length of the message, which is again defined by you, and then that's where it ends, right? So this is your packet of an MQTT message. This is what makes MQTT MQTT. If a message is sent in this way and you make your receiving device or the other thing on your internet parse this information, that means it is an MQTT protocol that is being used. Zigbee, another very commonly used protocol, especially in home automation. Zigbee is very commonly used because this, it's a fun story regarding Zigbee. This entire protocol was inspired by bees, their how they flock and how they move. This protocol is inspired by that, and it was published into I think an IEEE standard around 2007. But yeah, so another Zigbee, if you go into an electrical shop and shop for smart lights, they'll give you a special Zigbee controller which will be slightly more expensive than your normal Wi-Fi lights. Zigbee is supposed to be very good at power optimization, and again, when I say it's based on the bees network, it's supposed to be for a slightly complicated mesh network. So again, this is a really nice diagram of on what layer the on how Zigbee works, right? So there's your physical layer, which is 2.5 gigahertz Wi-Fi, right? Then on that there's your media access control. Then there is the network at which Zigbee Pro works, which is supposed to be more optimized than your Zigbee layer, the application layer. And yeah, so that's your Zigbee protocol. The reason why I stress more upon MQTT and the later protocols, that's CoAP and BLE, is because they're a lot easier to implement when you have your modules. Exactly, exactly. That is actually a very good analogy. All right, great job, you guys. Great job at following along. Okay, so this is again a slightly more complicated Zigbee layer. Let me see if I can All right. Co-op. So again, co-op is similar to MQTT. One of the people I was talking to right now, and they have EV swap stations, and we were just discussing solutions, and they said they recently moved from MQTT to co-op, and they're very similar. They're supposed to work in constrained networks. We'll see why they're different. So you can see that co-op is more like HTTP, and you can see how it's compared, right? So the payload, co-op, HTTP, there's the packet layer that's different, of course. Then there's the layer that it's using. This one uses TCP, this one uses UDP. They both have IP, and one's on an Ethernet link, and one uses constrained. That is a constrained environment. But this is a great example of what I mean, right? Your one system can have multiple protocols based on what you really want to achieve. So this network, you can see, you can one server, while it's getting connected to co-op, that entire mesh can also get connected to the HTTP network. All right. Oh no, I didn't go. I just wanted the screen to get bigger for you guys to be able to see the diagram. All right. So co-op structure, there are two different layers that make a co-op message a co-op message. That's the request response layer, and then there's the message layer. It's again basically the same thing. One is telling you that whether I am talking to you or whether I'm asking you for a message, and then there's the message itself in case I'm asking. And yeah, so again, MQTT also works on that basis. You subscribe and you wait for the message to arrive, and that's how it works. Over here, it works on a request response interaction. So the thing is, until you don't start designing your own solution, you won't realize when to use a co-op or an MQTT. So I'm gonna move on very quick. And this is again the co-op message format. You can see it's very very similar to the MQTT in terms of its structure, right? You've got a message ID, you've got a token which is basically similar to a flag telling what we want, whether we want to authenticate, and then there's the payload, and there are verification bits to verify whether the message is complete or not. BLE is one of the most used protocols. Anything you take, from your medical health devices that come, the smart health devices, to your music IoT devices, they all use Bluetooth very heavily, right? And it's a great protocol. It's low powered, it streams great audio, and yeah, I mean, it's got a great history too. I don't know if you guys have read about the SIG. Definitely do that. I'm not going to again waste a lot of time here. One thing I do want you to note is, we said that MQTT, co-op, they all basically run on the Wi-Fi layer, right? So this is something that I want you to guys to focus on, right? We're using the same spectrum layer, but because the way we're sending formats and the way we're communicating, the protocol changes, which is why BLE again is a different protocol and not really a networking option, right? So do pay attention to that point when we're designing our system. All right, so no questions. I'm gonna move on, or should I wait for any questions? Do you guys have any questions? Nope. All right. This is one of my favorite diagrams. It tells you how, one device, your one application will use different protocols to communicate with different sensors because of the type of data and type of application that's changing. All right. So for weight management, let's say there's a particular data. It's not that important, in terms of accuracy. It'll depend a lot on environment, so you don't really care about how accurate the data is, but you care about the size of the data, right? So you're going to probably use Zigbee standard. It's okay if it uses a little more power. You don't really care. Then you come to chronic disease management. Over here, your data needs to be secure. You need to make sure that the data that's being sent cannot be interrupted. So you'll probably use an encrypted BLE protocol. You also want the data to be not miss out. You can't just press a button again and send it. You want it to be very specific. If you've sent it once, it should show the log very accurately, so you're probably going to use BLE. Then again comes the distance, right? How do you want to be able to share it? So GSM, GPRS are a great way to get connected to protocols that are using the data layer. So once you use the GSM, GPRS, you can use more networks on top of that. So when would you use that? Would you use it for chronic disease management? Would you use it for vital signs monitoring? So these are some decision making that happens when you're using different when you're making your entire IoT system, right? Another great diagram, right? So you can see the different standards, how they can be further connected using the different protocols that exist. Now these protocols come under your internet networking, right? So how your health record also finally uses some protocol to go into the final database. So this is a great example of how thoughtful you can be when you're designing your system. For example, what you want to do after your app has collected the data, how do you want the data to be processed? If your data needs to go in a certain format, you'll want to choose a protocol that is slightly easier to parse into that format, else you're going to have to do a lot of processing on your application. So these are some things, when you look at the bigger picture, you realize the amount of thought that needs to go into it, right? All right. I promised I would keep that short, and I did. With through protocols, you've got a basic idea of how the protocols vary. They're basically optimized communication. Some are optimized for power, some are optimized for data, some are optimized for accuracy, and some are optimized for security. And we decide what's the priority and accordingly choose our protocols. And of course, we spoke about device choice yesterday. We spoke about all the parameters we consider when we're choosing a device. So let's quickly hop on to a project board and start designing a solution. So you guys gave a lot of problems earlier. I'm going to take something simple. We're going to take something simple, and I will drop the Miro board link. I'll share a Miro board. I'll drop the link. I would really love it if you guys just make a copy of that Miro board and follow along with your own problem, right? Uh, Let me share my screen. All right, so my screen's visible. Let me see if I can share it in a better way. All right, great. So let me see if I can maximize this or not. Okay, there we go. So I'm gonna drop the link. I think if you guys want to collaborate on this board, you're welcome to. It's just that I'm pretty sure that Miro won't allow more than 30 people at one time. So you guys can just make a copy and follow along in your own board. All right. So let's start by first defining the problem, right? So what problem are we taking? I'm going to take a simple problem. I want to measure the heartbeat I want to make a wearable, right? So let's start by defining the problem, right? The problem is monitoring night terrors. All right. This is my problem that I'm focusing on. All right. This board is something called a reverse brainstorming. So what's the worst form of the problem? It's basically reversing the problem. All right, I can see a lot of you have already joined, which is great. So feel free to edit too if you want. Just make a copy of this board. All right, I'll make you some copies, and if you want, if you want to add to this, you want to add your problems right here, feel free to do so. Ah, all right. So take a sticky note, grab a sticky note, and add your problems here. And do add your name so that we can talk about the different problems once you get there. So let me give you around 3 minutes to add your problems. Okay, my bad. Let me change the can edit. I will add another link here just in case. Okay, health tracker. That's a great suggestion, Ritu. I have a feeling the board will kind of limit after 30 people join in. So in case you're not able to join in, let me know. I'll create another board and share the link. It's okay. The boards moved a little. We'll just zoom out. Okay, I'm going to give you guys 2 more minutes to put in your problems and then we'll start solving them. It's okay. Miro boards aren't easy to work with the first time. You can play around with it until the time we understand what's going on. Okay, someone dragged the entire thing away. It's okay. We remember that we're adding problems here, so just keep adding problems. Another 2 minutes. Go ahead, add your problems, and we should be good. Let me know if you guys want the link again, or if you guys need me to create another link, we'll do so. That is a great question, Rishabh. So a Miro board is basically a team board. So it's for your team to come together and collaborate. It's another collaborating tool. So like there are multiple others, right? There's Google Jamboard, then there is Microsoft Whiteboard. So it's something similar, but it is specifically for collaborating and brainstorming together. So I used it for the first time in a design workshop myself. It was something similar, except it was more for social causes. So, yeah, I liked the idea of collaborating in a workshop. So, here we are. All right, guys, the time's up, and I see some great suggestions. And even though I can't see what the entire frame was about, I think it's okay. We'll figure out what you want to do anyway. Let me see if I can bring another frame back. All right, so let's get started with the solutions. You guys have suggested some great problems. All right, so here's what we're going to do. All right, I'm going to start brainstorming about on the solution on the problem that I suggested. You guys can follow along for your problems the same way I do, right? So the first thing we're going to do is we're going to reverse the problem. All right, so what do you mean by reversing the problem? Okay, someone has suggested this, and I'm going to make it slightly smaller so that we can focus on the other problems as well. All right, so let's make sure all the problems are visible, and let's start with this, right? So we started with I want to monitor night terrors. So what I'm going to do is I'm going to create a new sticky note right here. Okay, let's see if I can change the color. Okay, I can't. Okay, so I'm going to start by reversing the problem. What do you mean by reversing the problem? What's the worst of not being able to track night terrors? It's causing night terrors, right? Now, I know I'm not going to sit and design a, a solution for causing night terrors. So let me simplify the worsening of the problem and is measuring after the night terror is over, right? So that's my reverse problem. Okay, so that's my reverse problem, that is it can't. So now what you guys need to do is I agree Miro is kind of, it ended up becoming a little chaotic. I'll think of better ways, but it's trial and error, right? So it's okay, people are having fun. You guys will have a takeaway and a link to share later, so great. Thank you, Rishabh. Awesome. So now what I need you guys to do is make a sticky note of reversing and worsening your problems. So let me give you an example from what you have given. Health tracker. So instead of what's the worst health tracker that can exist, that it tracks everything after it's happened. Something similar to what I suggested. So take a sticky note quickly and worsen your problem. Like make the worst case, reverse it. Basically, your problem should be the solution to your worsened problem. All right. Save passwords. That's an interesting problem that I'm sure we're gonna have fun solving with IoT. There I see light sensitivity control based on sunlight in the room. That's a great suggestion. Security system. Okay, now I'm seeing you guys worsen your problems. By the time you do that, I'm gonna talk about what we're gonna do next. All right. So yep, you'll get used to it indeed, Devang. Thank you so much for the reassurance. Again, cannot say that enough. All right. So what we're gonna do next is we're gonna list down the features. Okay. So that's the problem. Then I have the worst problem, right? Then what I'm gonna do is I'm gonna list out the priorities with which I want the problem solved. So for example, if I want to measure night terror, first of all, it has to be a variable. It has to be a comfortable variable, right? Sure, Rishabh. Let me talk about worsening of the problem. So, what we're trying to do is we're trying to reverse brainstorm, right? So, to get the best case scenario, what we're first doing is we're looking at the worst case scenario. So, you define your problem. Now, what you want to do is you want to define the worst case scenario of that problem. Uh, like your problem, what you've defined should be the solution of your worst case. I didn't get this, but all right. So, did that make sense, Rishabh? Okay, I'm gonna take that as a yes and move on. Awesome, good. So, you guys go ahead, define the worst case scenario. I'm just gonna babble a little more about how I'm going to define the features. Once you start defining, I think you'll get a better clarity when I kind of read through and tell you why it's great or why it can be made more great. All right. Okay, so I'm gonna take another sticky note. I'm gonna take a colorful one this time, and I don't know where it went. There you go. So features. So I'm gonna prioritize. So I'm gonna have three columns. That's priority. Okay. I'm gonna have first is priority. Then I'm gonna have add-ons. That is to kind of aid the priority. Aid the priority. And then the third one is going to be giving your product an edge, right? Giving your product an edge. So of course, if it's a problem that's known, most people are trying to solve it. So if there is another product, how do you give your product an edge over the others, right? It's kind of a part of the designing solution. If you think slightly ahead, like I said, right, you saw the bigger diagram in which in case if you can think when you're designing a system about the last endpoint, how your data is going to be viewed by your end user, and accordingly tweak something that helps that get better. It's always a bonus point. So let's start with priority, right? What's the first priority of my device? That is being able to first it needs to be a variable, right? It should be a comfortable variable. That's my first priority feature. Next, it should be able to track a vital, right? So this will give me an idea about the sensor that I want. So track a vital, let's go with a pulse sensor, right? What's my next priority? It should have a power optimization, right? That's my three features. What are the three features? That first, it should be a comfortable wearable. That's one of the first things in my product, because I'm not thinking just about IoT. I'm thinking from a product point of view. The first, it should be a comfortable wearable. Second, it will need a pulse sensor. Third, it should be power optimized. Now, what do I understand when I've said these three things? If it has to be a wearable and comfortable, now you have an idea of the material you'll be using. Your material will also be one of contributing factors in the type of protocol you will be choosing, right? If you are going to use a comfortable cloth based material which is going to cover your circuit, because you don't want the circuit to be felt by the person wearing it, it might, and if the if you're sending it over BLE, it's probably not the best idea, right? There are very high chances that the BLE gets disconnected. There is multiple connections, and or the data gets kind of obstacled, right? So again, this is a very vague idea, but I'm telling you this is how you kind of start, right? Then there is second part. The second priority in my feature that I've said is it is has to track a vital, right? That means it has to be a pulse sensor. That means the actual sensor needs to be should contact my wrist, right? Because I'm making a wearable, I'm making it a pulse sensor, I'm thinking of it as a wrist based device. So this is my design thinking happening, right? Then the last is giving your product an edge. Can I make it more useful than just tracking the pulse, and maybe running an algorithm to give or detect a night terror? All right, so that's the first thing, right? Next is aid the priority. What will aid the priority? Something like an auto rechargeable device that recharges from sun or recharges this from a dynamo. So maybe let's say renewable power source. From a design point of view, you can think about it to be skin friendly, and if you're trying to think of a target audience, see, this is another great suggestion. So exactly, you need to think cloth could get torn, but then how do you make it comfortable? You're going to have to teach us a little bit about the material, and when you uh, design it as per these situations, your electronics and your actual protocols will automatically fall in place. All right. Exactly, Satya. That's, or Sati. I'm sorry. That's exactly what I mean, right? It has to be. It has to have some more USP than just the general problem that you're solving, right? All right. So this is one way to think. And then what gives a product an edge? I also predict, right? Predict night terror, right? Of course, this is more on the algorithm side, but this is something that I can think of. Let's say now that I know I want to give that edge of predicting, I'm probably going to choose a sensor that is more sophisticated than your regular pulse sensor, on which I'll have to do a lot of data processing, right? So, great. Next is, now comes the IoT part, finally, right? So now you have a problem, you have the worst case scenario, and based on both of them, you've decided the three layers on which your product will be based. First is the priority features, that is the things that are actually solving the problem. Then there is add-on features, something like a sound that wakes up the person if they're having a night terror, or maybe a vibration to kind of bring them out of the uh, anxiety spiral down that they're having. And then there is the edge in which you can predict and you can make the device, maybe tell more things. But if you think a couple of things from right now, but not focus on them, but have them in your mind, your choices will be more intently towards an entire product than you just iterating over and over again, changing every part. Okay, so great. So let's start with our priority device. Let's start with the first tiny device that will be an IoT system, and it will solve your problem, right? What will your device be? So let's first look at the device. Okay, so you want it to send data over the network, right? It has to be an IoT device. Okay, it has to so your device that you're selecting should get connected, should be have the ability to get connected over the internet, right? uh any suggestions there? What device should we take? I told you, so we can use a chipset and connect it to a module, or we can take a chipset that already has a module connected. Any suggestions? Any product suggestions? Any, throw out the words, people. Arduino, ESP8266, 32. Great job, Rehan. Great. So ESP32 Nano. Great. It's a small device. It only has to process one signal. Great job. Alrighty. So I'm going to select something called the NRF52, right? So NRF52. Why? We'll look into that later. Okay. And NRF52 is more of a umbrella term for multiple chipsets. So have you guys heard about microbit? For a microbit, so that you guys have a much better understanding of what we're doing. All right. Okay. Let's see what you guys have been up to until then, though. Okay. I just realized the entire thing has vanished. Great question. Let me just come to it in a minute. Before, I just realized my entire Miro board has kind of vanished. I'm not sure who did that, but all right. We'll figure that out later. All right, so what's the difference between a chipset and a microcontroller? Chipset, so your microcontroller, right? Let's say your Arduino Uno. It's a development board, all right? So it already has a lot of things on it, from your transistors to your pins pulled out, right? And I agree, Shrikaran. I'm regretting it a little now, just a tad bit. I am honestly quite not sure if I haven't done the action whether I can undo it, but I'll definitely try to in a bit. It's okay. It's okay. We'll till the time you guys are following along, we're good. Okay. So your Arduino board, say your Nano, Uno, Mega, even your SAMD chipset boards, right? They're your evaluation kits basically, right? So what's happening there is you have a chip, and it has certain capabilities, right? It has a defined you can go through the data sheet. There are multiple things that are defined, right? So let's say they say it has 5 GPIOs, and the 5 GPIOs can do certain tasks when connected to certain elements. So what the evaluation board does is basically pull them out and make them more accessible, so you can just connect your sensor and things work. So take your ESP32 and take I2C, for example, right? For if you're using the chipset, you need to give pull-ups. Do you guys know what are pull-ups basically? So pull-ups are basically to kind of uh, I'm not sure how to explain this. Let me see. Okay, so basically your chips evaluation kits are easy to use chipsets. Your chipsets have been made more accessible by the provider so that you can use the chipsets. When you're building a product, you don't want to have unnecessary power consumption uh, based on all the extra features that have been given just for testing purposes, right? For example, on an Uno, you can connect I2C, SPI, digital pins, analog pins all together. But when you're designing a certain product, you don't really want to do that, right? You only, let's say right now we're using a pulse sensor. All you want to do is you want to connect your pulse sensor, which let's say runs on UART, right? You have one digital signal coming in. You don't want the rest of the pins to be used. So what you'll do is you'll only use the chipset that's being used. Let me see if I can show you a data sheet of like Alright, so do you guys know what chipset Arduino uses? Any guesses? So Arduino uses Atmega chips, all right, and let me quickly show you what comes up when I Google Atmega. All right, can you see this screen? When I googled Atmega 328P, you see that there are multiple. You see this? This is the chipset, and your Arduino, if you look closely, is using that chipset to give you all the features of that chipset. So this basically is something as simple as this, right? This is an AVR based controller, and you have these things. But remember, when you look at the data sheet, you can't just simply connect them, these pins. You need to have certain protection circuits to use particular pins and particular features. So what Arduino does is it kind of makes a circuit for you, and it gives you all the add-ons. So if you ever zoom in into an Arduino board, let me just see if I can do that. There you go. So you see these power circuits. So if you're when you're powering it, automatically there's a voltage regulator. These pins, they're all connected to different transistors and resistors. And like I mentioned, pull up, right? I'm still trying to figure out how the best way is to explain a pull up, but basically it has given you a lot of features of the chips easily accessible. When you are building a product, though, what you want to do is you only want this chip, and you want to only use that feature that you want to use, right? So that is again the difference between a proof of concept in which you're using modules and a prototype in which you're just presenting the entire uh, solution, right? All right, let me stop sharing and share screen window. I understand that my Miro board's empty now, but that's okay. I'm not sure how you guys managed to do that, but okay. Okay, I'm so great. I am happy that you did. Any follow-up questions are welcome. All right. So this is basically what I mean when I say that designing is a thorough process. It's not just picking whatever is available or following a tutorial, right? When you're designing an IoT system, there is more to it. All right. Great. So now, since my board's empty, what I'm going to do is I'm going to go to another board, create a new board so that you guys do not get to delete it. And I'm going to list down the features very quickly again. And then we can move on to the hands-on part where we actually start setting up our environment. All right. So there you go. Sticky note, priority features. First is, what was the first feature? First feature was being able to have a comfortable wearable, because you don't want the device to cause night terrors, so it has to be a comfortable wearable. Second feature, what's the second feature? Is vital sign measurement. And third feature was power optimization. So let's just focus on these things, right? What we were going to do for the solution was we were first going to decide the chipset. So the chipset we chose was an NRF52 chipset, which was a microbit evaluation kit. Microbit is again something similar to Arduino, where it utilizes the functions of an NRF52 chipset. All right, great. Then I'm going to take a pulse sensor, which basically gives me a digital signal when there is a pulse, right? That's my pulse sensor. For my power optimization, I want it to be a rechargeable battery, so I'm going to use a lithium polymer battery with a rechargeable rechargeable circuit. Now, do I want the battery status to be visible on the internet is something that we can decide later, right? Let's put a question mark here so that we remember. All right, great. So that's first brainstorming feature update. Next, we're going to figure out how these things are going to communicate, right? So for a feature over here, we'll also add a dashboard, right? Now, this can be an Android or a web-based dashboard. Let's stick to web because it will be a lot easier to visualize. All right. So next is how are they going to communicate, right? So first, my digital signal is a simple one or a zero that is being received on my end. How will I take out the processing of the data? It will be the frequency of the pulse sensor input signal. Make sense? All right. Then what's our next feature? To be able to send that data. How do we want to send the data? Now remember, it's a wearable device, right? It's a wearable device. It needs to be power optimized and it should be able to go into deep sleep when it's not being used. It should be automatically be able to, you shouldn't have to turn it off to not be sensing your pulse, right? So suggestions for protocols. What protocol do you think should be used here? We went over MQTT, Zigbee, CoAP, BLE. Which one do you think is the best protocol that should be used here? Or if you have a new protocol that you want to throw in, go ahead. Great suggestion, BLE for security, but think about it. You aren't really sending any confidential data, right? It's just a signal that's every time your pulse is gonna go high, it's gonna detect it and it's gonna give you a voltage and it's gonna give you a digital signal that hey, your pulse went high. If your pulse is going, it's if you're you have a higher pulse rate, you're just gonna get more ones, which is why we said frequency of the pulse sensor input, right? Is the frequency really is the security really important for the frequency that we're sending? That's a suggestion. Do you want to explain why? Why do you want to choose Zigbee? Zigbee again. Why Zigbee though? You guys seem fond of Zigbee. Why? Come on, you guys. Why Zigbee? Why not BLE? Why MQTT? If so, okay. Have you noticed what most devices use? What most wearables that you wear use as a protocol? That's a great reason, Devang. That's a great reason. But remember, they're not coming from different devices, right? Your sensor signal processing, that's your first layer of your architecture, remember, that we studied, in which we're just processing the first amount of data. Your sensor is going to send data, your microcontroller literally has to take the data, make it more readable. That is, your data that's probably going to be sent to the cloud, it does not even have to be sent continuously. It can just send when, let's say, you can do the processing of the pulse rate even inside the controller, and then send if need be to the cloud. You don't even have to send it continuously. Does that make sense? But you had a good thought in your mind that your sensor and signals need to coordinate well, but they're not overlapping each other. Every time your sensor sends a signal, your microcontroller is going to receive it. All right, so if you ever notice, most of your variables use BLE. Why BLE? Of course, security, BLE has the most, but more than just security of the data, because the data is confidential. In this case, it isn't exactly confidential, or of course, you don't want to distribute it, but people can't really do much if it's even encrypted or if it's even interrupted or interfered with, right? So why do you want to use BLE? First of all, you want it to be a low range network. Why? you don't want to stream your pulse rate, especially if you're measuring night terrors, right? It's supposed to be an immediate action thing. It's something, your next actuation has to be in your immediate surrounding, right? For example, your Apple Watches that detect fall, right? That has to be in your immediate surrounding. It does not have to uh, send a signal far off anywhere, right? Exactly, Devang. So it's low range. You want your immediate surrounding covered, but you don't want like more than a couple of meters covered either, even though BLE gives you a much better range. It gives you almost 10 meters today, right? So let's stick to BLE for the time being. All right, so next we have our BLE protocol. How we use BLE protocol though, how we use the profiles. BLE has some great health profiles already built in, so you can just use the protocol as it is. Oh, so great, right? So BLE protocol. So that's our next feature. Then is our sensor itself, right? We're thinking of a final variable. So our sensor communication. And lastly, we want our battery communication, right? Okay, so now we have our product ready. Now I know you guys kind of blew the board here, but if you guys still want to go ahead, put your entire design thinking process onto there. You're welcome to do that. In case you created a copy, great. If not, I'll share it again. I'll share the template in the GitHub repository that I shared earlier today, and you should be good to go. Okay, so let's move on to the hands-on part now. Give me or tell me in the chat if you guys have your Azure account set up, or you guys need me to set it up for you, or like set it up together. Do you guys have an Azure account? Do you not have an Azure account? Perfectly fine. I'll help you out. I'll just walk you through how to set up. It's pretty simple. I am very sure you guys will be following along in no time. Right? So let me share a new window altogether. Well, that Miro thing was a disaster to say the least, but it's okay. We'll try something new next time. Uh, where is my Alright, let me know when you guys can see my screen. So this is a known problem. It does not automatically take the student offer, so you'll have to connect either your student email ID or go for the signing up of the student pack, in which case you have, I think, 5 ways of verification of your account. Let me see if I can show you that. If not, I'll make sure you guys get help later on. Okay, awesome. Thank you, Devang, for confirming. Okay, so let's just go here and go to Azure. There you go. So I, of course, have signed in, but what I will do is I'll just Google Azure and start from scratch. There you go. You want Azure. Let's try Azure for free. I think there is a special URL for students to sign up, but I think even if you start free, that works. Uh, we don't want that, do we? Let me see. Okay, I'll show you how to go about this. in case you're already signed in, uh, what you can do is you can go to subscriptions. All right. In case you're not signed in, I suggest you guys use your college ID. So this is what I do. My college ID, my college has active Azure directory already, so it's easier for me to uh, access my student benefits. But most colleges I think already have that. But in case you don't, here's how you go about it, right? So these are my subscriptions. If I want to take a new subscription, I go here. All right, and it's going to show me all the different offers available. So once you go here, you can go here and select, and then there's the entire sign up process that should work fine for you. All right. So does that make sense? Do you guys need me to send this link? I think this link will be helpful. Let me know if you guys are following along. I'll stay back and wait on the step, else we'll move on. Alright, another thing while you guys sign up or figure this out, I want you guys to be aware of is Anaconda that I like to use for Python. We'll be using Python, like I mentioned, for running the scripts. I like running Anaconda because I have multiple different programs running and different dependencies and different versions of Python. So, what Anaconda helps me do, in case you guys aren't aware, is it helps me create these environments with which my dependencies don't break in other environments. So let me share my Anaconda screen. Let me know if you still need help signing up for the Azure pack. I'll see what I can do. Until then, let's see. Stop search. Alright, so you see, this is the Anaconda navigator that you'll end up installing. Okay, once you do, you can. So this is where you'll possibly land, and there are multiple other tools that are available that are really useful in case you're into development and into hacking. So VS Code, of course, is what I use my Anaconda with. Then there are some others. There's other stuff like Jupyter Lab, Jupyter Notebook, RStudio, and so these are the things that I use in which there is no install button basically. So what you do is you go into environments, you can create a new environment, and you can decide what you want in that environment. So for example, let me give you this one was another IoT project that I was doing for a company, and I was using a lot of MQTT in that. So there were a lot of MQTT based programs that I had to install. This way, if I was installing a particular version of Python or Python based dependencies, my other environments didn't really get affected. So I completely suggest using Anaconda. I find it a great way to go about things. I'll show you how I use the different setting in the VS Code as well once we get to that point. But do set up Anaconda when you can. All right. Can I have a status update on if you guys are signing up for Azure? Rihan, Devang, any updates regarding if you guys are following along, if you guys need more help? All right, not an issue. That's okay. I'll just walk you through the different things and different tools that you should possibly have. Let me see if I can drop the Anaconda link for you guys to download. Okay. I'm dropping the link for Anaconda as well. Go ahead, download it on the side. Um, Another tool that we're going to install together is the Azure Iot Python Sdk. You'll see that today itself, if you guys get your Azure set up, we'll have a device sending data, our simulated device sending data. All right. Is there anyone who's done with Azure and wants me to follow along the next steps? I'll take that as a no, and we'll move on to the next thing that we're going to be doing, right? So what we need to do is basically we want to open the command terminal for the environment that you built for this. So let's say, okay, so this is hung up for me. So what I will do is I'll share my VS Code and I'll share my command prompt with you instead. All right. All right, you know what? I'm going to share my entire screen and there you go. So if once you click on the environment, it should create a virtual environment for you automatically, and you should see this. This is what I've made for our workshop, and I'm already in this GitHub repository that I'll be pushing all the code to, right? But what you want to do is, let's say, okay. So what I'm going to do is mpdir workshop live. Okay, what we're going to do here is we're going to clone the GitHub Azure IoT SDK for Python. All right, so let me quickly give you the link for that. And there you go. That's the link to Azure IoT Python SDK. And we're going to be using this for our simulation. And I lost the stream, yeah. Oh. That's a good idea, Devang. So I'll just show you a quick setup because I want to end this in the next 3 minutes, and you guys can follow along in the later tutorial. I'll put a detailed list of instructions in the GitHub repository in just a few minutes after the workshop's over, and you should be follow along. You should be able to follow along just fine. All right. So I'm going to again share my screen and show you what you're really going to do. Right. So let's go here. Let's go here, go to new tab, and we're gonna do this. This is what I shared with you, and what you want to do here is you want to clone it. So if you guys followed along any of the GitHub workshops, this should be fairly easy to. Otherwise, also this is exactly the command you need to follow, right? Once you clone into this, that's it. That's all you need to do to get started and set up. And once you're set up, we'll just be writing scripts tomorrow or day after, whenever our next schedule is. It's a little tricky with the time zones, but yeah, the next session, what we're really going to do is we're going to finally work on this environment that we've set up. I'll send you all the links you need: Anaconda, Azure, and the SDK. That's all you need to create your entire project. We will study the sensor behavior, and we will create an entire project. All right, any questions regarding what we did today, the design process, the feature planning, protocols, RTOS? If there are any questions regarding RTOS, do go ahead and ask, because when we study this FR code, it might get a little complicated. No questions. This is the GitHub repo that you need to follow. Oh, you mean the one that I'll be sharing? Okay, I'll share the one that you guys. I thought I sent it in the Discord yesterday, but I guess I didn't. Let me share it right now. Alright, so I have put the link in the chat, and the PPT for yesterday is available there, and today's PPT will also go there, and all the instructions, including the files that you really need. If you can't download the entire SDK, that's okay. If you only download the repository I'm sharing, even that should be good enough for you guys to get your entire project running. All right, so I'm going to close the stream now since there aren't any questions. I understand it was a chaotic session today, but I hope you had fun during the feature planning part. And I'll see you guys in the last session where we'll actually set up the entire project. All right, so if there are no questions, I'm going to end the broadcast now. Awesome, great. If there are any questions, again, reach out to me on any of the social media channels. I am happy to help you out. All right, bye, you guys.